You are.
Yes, you are.
Awesome. Let me start.
Thank you.
So, thank you everyone for attending tonight. Like Christian said, I am in New England, not to be confused with England. And I'm in the smallest state in the Union, okay? So, this is a slide deck that I'm going to present tonight, but I was trying to find one last link. And so, anyways, all the work I have, you can go out to John Miner 3 Community Work, and it's freely given. So anything you like, just grab it. It's yours to use. If there's any bugs, you can tell me, but don't blame me. I do my best. Today we're going to talk about different files that you can use in Fabric. And so I am trying. I got too many presentations here. I am trying. Oh, here it is. I knew it was somewhere. If you want to download it, this is the actual place to go. So I will paste that in here. This is a very specific one tonight's talk. And we're going to talk about different file patterns, okay? So again, this is my GitHub repo. Go there. Awesome. I've been having the pleasure to write for two different national blogs, okay? The first one was with Steve Jones. You probably know Steve Jones because if you've done any SQL work, he runs the SQL Server. Well, he did SQL Saturday, started off back in when, and I've been attending those with Christian and Michelle for a long time. But he also did SQL Server Central. And so, if you're interested, all the content that I've been posting on SQL Server Central has to do with Fabric. So it's regardless if it's a warehouse, the lake house, it's shortcuts, whatever you want to talk about, it's there. Another person I've been friends with and been writing for a long time is Jeremy and what's his name? Greg Rubidoux. And that is MS SQL Tips. So if you're curious about, like, hey, what is Azure? And it's kind of cool that we're at Fabric because Fabric nowadays does a lot of stuff for you. Back in the day, I'd have to deploy storage. Well, you got storage already, right? And I also had to worry about networking. I don't worry about that anymore, right? You might have to do a few things like start up the capacity, but other than that, it's pretty much available for you. Okay. So I was just checking out my demo. This is the demo. We're going to talk about different things like SQL Server, and we'll also talk about PostgreSQL and so on. Um, this SQL Server, let me double check where that's coming from. I might have to turn one thing on, and then we should be good. No, actually, I think it's coming from a file share. Did I get it from file share? I don't know. We might have to do a change to that. And if you don't mind staying on a little extra, we'll do that. Let me go ahead and find out where it might be. And again, I apologize for being a little slow. Just had dinner. It's been a long day. Getting into the groove, going, maybe I want to take a nap like Michelle was talking about. She was looking at my sofa and thinking about jumping on it. um, okay. Looking for the last thing, and I don't see it here. Where is it? I mean, it's not this guy, not that guy. Too many resource groups. Not that guy. Not that guy. That's the Postgres one. I thought I put a spin up a SQL Server. Here it is. Can't read. Okay. And do. Okay, so this is the virtual machine, and we can talk about that. Okay. So now I got my environment set up. Let's talk about Fabric. The very first thing you need about Fabric is before I get into Fabric, I need to start a capacity. Okay. Every single workspace has a capacity. So if you go to my workspace, we go to workspace settings. Okay. And eventually, I find that always time when I do a demo, everything slows down in Fabric. I don't know why. It's just the way it is, right? But North Central U.S., there's not too many places you can pick, so that's why I picked it. What's the SKU? It's an F16, roughly around 16 cores, right? Question you might want to be curious about is guess what? How much it's going to cost me? Because, it's kind of cool to be in a setting in which, you have everything in the cloud. And I don't know why this is not here, but I will remove this. But now we have to worry about, chargers, right? And so hit OK, and I'm going in here. So we can see the SKUs in F16s, right? And the interesting thing is, how much is that going to cost me? If I ran that every hour of every day, and Christian, he likes bumping up to an F64. That's like 8 grand a month. I don't even go there because I know that will be a problem if I forget about it, or even for a few hours, right? Because, it's pricey per hour. But we're using F64. But you can scale up and scale down. And one of the articles I showed you talks about logic apps. And did I come up with that idea? No, I actually begged and borrowed it from Christian. So thank you, Christian, for giving me that idea to talk about. So we'll move these over, save it. Let's get into the slide deck. We'll do some work. But once you have that open, basically you can log in, right? So we go into app.fabric. You can pick the date. There's different experiences. Like there's a data engineering experience. And that means you'll be working with a lakehouse or a warehouse or data pipelines. We're not going to talk about those because I could spend like 8 hours talking about Fabric. And it's pretty big. And there's a test out there called the DP600 that is very big. You can learn about a bunch of tools, right? Like Power BI, the lakehouse, the warehouse, and everything in between. There's a new one out there called DP700. I haven't gotten to it, but it's basically on data engineering. And that's where I pretty much work, in data engineering. And there's two flavors of data engineering that most people, hire me as a consultant. First one is a warehouse, right? So it's that SQL that you know about all the time. We're not going to talk about that today. We're going to talk about the lakehouse in different file formats, okay? So with that said, I am going to turn off my camera, okay? And we're going to get into the classwork. And with the classwork, we're going to do demos because that reinforces what I talk about. So let's get this right. And I'm going to hide this show prevent of you and then hide it. Perfect. So again, welcome to tonight. We're going to talk about file formats for Fabric and again, Lakehouse, not the warehouse. My name's John Miner. I'm a data architect. I've been teaching for the last 15 years, and I've had the pleasure for hopefully year number 10 as an MVP. If you're curious and you're in the States or need some consulting, we're all consultants. John.miner@insight.com. That's my email address. Okay. With that said, let's talk about what we're going to talk about tonight. Basically, is Fabric old? And the answer is kind of maybe, and not really that old. Like I started with Pascal back in the 80s. That's old, right? Or I started in C, and C came out in the early 80s, if not 70s. That's really old, right? Fabric it went to GA in 2023. Now I heard about it 2 to 3 years before. They called it Project Trident, okay, as an MVP. Right now, there's 4 types of problems you can talk about and solve. These are the core areas in which you can build stuff in, right? Custom code. You can do a lake house, right? So we can populate data, okay, using Spark to data engineering, and that's what we're going to talk about tonight. But if you like a SQL statement, right, like create table, drop table, right, insert into a table, select star from a table, delete from a table, update a table, then that's the data warehouse, okay? Data science, again, we could talk all night about it. The problems you solved, right? And it has ML flow built in. And then real-time analytics. And some people complain about it there. Last time I looked at it, it was interesting. Not 100%, reliable yet, at least compared to what I do. So, I like to be Spark and I like stuff that's been around a while. So like Event Hub, perfect, or a Kafka compliant device, perfect. Okay. So today we're going to talk about how you can use Fabric and how you can solve problems regardless of the data types. And there's a lot of data files out there. Like I said, I've been doing this for about 35 years. I started in 1991, my first job, and I also was a consultant for the Navy a couple of years before that. So been doing this for a long, long time. Topics. What is the Spark ecosystem in Fabric, right? Because we want to know, Spark's the heart of everything. And I'll throw out some names. For instance, AWS has Glue, and it's on top of Spark. You want something cross-platform? Let's talk about, Databricks. Perfect thing cross-platform. The Lakehouse has Spark. Okay, so it's really important to know what Spark can do out of the box, regardless of what Microsoft added to it. Okay. Second thing is people have been talking about Medallion, okay? And I'm not talking about, we're at the Olympics in which you have bronze, silver, and gold, right? But it's kind of like that, right? Oops. Bronze is weaker when it comes to quality versus gold. And some people even actually, make more ones. Like maybe I don't want bronze, but I have a staging area. Maybe I call that tin. That's okay to me. And maybe you have gold, but then maybe you take the gold and you weed through it and you say, hey, these are just executive reports. Maybe I want a platinum area, right? So again, you can modify the medallion architecture to fit your need. The question is just basically compartmentalize the actual quality of the data and who you're using it for, okay? Now, you might hear, strong versus weak, right? When it comes to file formats. CSV, very weak. Parquet, very strong, right? So we'll talk about that. We also have to worry about how long does it take to move stuff in the cloud, right? I had a client, and again, I'm not going to say any names, but once a month they copied over 4 terabytes. Azure must love them, right? And then after they did all that time of copying the data, and they rebuilt a warehouse from scratch. And the reason why is they said, oh, we don't have any type of primary key and some type of watermark to do incremental changes. And I'm like, come on, there's a ton of products out there, like Fivetran that will read the log, but they didn't want to hear it. So they're still rebuilding a 4 terabyte database once a month. And there's other people I know doing similar things on premise. So crazy stuff. But in the cloud, it's important to get the data up there quickly, right? It costs less, takes less space, so zipping up is important. We'll talk about all the formats files that's supported by Spark. And last but not least, key is working with RDBMS data source, right? Everyone has a database out there, okay? And today I'm just talking about formats that are structured, right? There's plenty of unstructured stuff you can talk about too. Like for instance, we talked about reading from Event Hub. That's JSON documents. Or you can call a web API, and that's kind of out of scope for this talk. But we're talking about stuff that you'll normally see that's probably been around for a while. Okay, so what is Spark? When I got out of college, there was no such thing as Spark except for Leonard Nimoy, okay, for Star Trek, right? He was Spark. Basically, Spark came about in 2010 with a project at UCLA Berkeley, I think. And so, again, I might be misquoting it, but the main thing is it was someone's PhD thesis. And what they were looking at is that Hadoop is really slow. And the reason why is we know disk is slower than memory. So they're like, why are we doing all this processing on disk? Do it in memory and then write to disk at the very end, right? And that was the big paradigm change between Hadoop and Spark. But there's 4 key problems that you can solve out of the box using Spark. You can do data engineering, that's the top left, right? You can do it either with SQL syntax or data frames, okay? Second thing is machine learning, and I'll give you a couple examples, but again, this is not a machine learning class. For instance, maybe we want to predict something like the cost of a diamond, right? And if there's a good study out there on Kaggle, if you look, and cost of a diamond like depends on a bunch of stuff like cut, clarity, and carrots. And if you look through them all, guess what? Carrots is really the main driver. Okay. And some of those things are really interesting. Like maybe you get an R3 linear regression with it. Okay. But there's other things that are getting really exciting, like LLMs. And I've been doing a lot of work with LLMs, and they were awesome. Like, for instance, you have some SQL code that's from SQL Server, and you need to move it to Fabric. And guess what? The data types are not the same. And it doesn't support everything like, all this type of stuff that you could do in SQL Server, like the pad index and on a file group and etc. How do you translate that, right? Well, if you're lucky and Microsoft got to mirroring and you're willing to try something that's in beta, go for it. Or second thing is you could use a data pipeline, but you still have to create the tables, right? LLMs will help you generate code to do that, right? So I'm working with a client right now doing that. Streaming. Streaming's awesome. You can read, structured streaming, like people drop stuff into a lake, you find something new, read it. And that's the whole core of autoloader with Databricks, but there's no such thing as autoloader in Fabric. But you can do structure stream, and I wrote a whole article on that. And there's Graph. I hadn't really used Graph, so if anyone's used it, I'd be interested to know about it. It's on my bucket list to learn with DBT, but there's only so much time in the world every day to do something, and I haven't learned them. So let's talk about a Spark cluster, okay? And I'm going to minimize this for a second and bring up this to show you a real world example, okay? So I have a data warehouse here. I have another data warehouse here. I got some environment stuff like connections, right? And then I have job sales. This is an environment for working with Postgres, environment working with SQL Server. Why are these here? Well, the problem is when you work with those, you have to load a jar file, right? And jar file is basically a connectivity, okay? Different vendors do it differently. Databricks, I like it because you can go search for it. This one, you just have to find it and load it up. It's not a big deal. But what we're going to work on today is this directory called LH file types, and that's a lakehouse. And there's a SQL analytic endpoint there, as well as a model that can be used with Power BI. So we can go to demo 2. And the very first thing we're going to do is we're going to clear some Hive tables, right? So let's clear the Hive tables. When we go in, there's 2 flavors of notebooks. So that's why it's saying, hey, is it a T-SQL notebook? And actually, Christian might say, oh, there's 3. And it kind of is 3. I'm speaking of myself. If you don't want to use Spark at all and you just want to use Pandas and you're doing something simple and you don't need a big cluster, you just can run a single node, go with Python notebooks. They're really cheap. T-SQL is that warehouse stuff that I'm talking about with that client. And then it's the traditional Python. And you have different flavors. Python and for PySpark, you have Scala for Spark, you have SQL for Spark, and you have R, okay? Most people are using SQL, so that's what I'm at Python, so that's what we're going to do. So the very first thing we're going to do is just clear this out because we're talking a new talk, right? I want to clear it out. So I wrote some code that says, hey, show me all the tables. Now give me a list of tables. For each table, now when we do collect, it comes back with a list, right? A dictionary. For each of the table and tables, if the table.name is not equal to metadata, then say, hey, I don't want to do anything, right? And if the table name is SQL Server, then don't drop it. Otherwise, what we're going to do is first try to drop the table, and then we're going to drop the view. Okay, so let's start this. There's 2 ways you can do it. You can do a new standard session or a new high concurrency. I'm going to do a new standard and show you the reason why. This is okay, but you might have issues, okay? Because if we let it go, we only have so much compute, and this will stay open and start sucking compute. And it's kind of like, it's one of those things like Databricks really excels at. Microsoft's still using the same paradigm. We'll see. So we started a compute. This one is just comments, right? You can see it. We could have done Markdown. There's different types of things you can do in notebooks. And right now, this is going to go through, and it's running, and it's thinking about it. Okay. So now it's saying do not drop because it must be all those, and it's dropping the CSV, the JSON, and so on. And one of the things I'm really frustrated, and Christian, have you noticed this, that they keep on messing the code up for the data warehouse in which the tables don't all show here?
Why is that?
They keep on introducing the same bug I reported.
Yeah, reported at least, right?
This is the 3rd time I reported. I'm like, okay, can I get like special bonus for reporting the same bug 3 times?
You're MVP, right? So
yeah, I know, but can I get ME3 cubed? Give me 3 times the credit?
Probably, yeah.
Exactly. So there's some directories here, and let's talk about it. We'll work with each of these data sets. So when you click this, it's a directory. And inside a directory, you can have subdirectories, and we have the Iris data set. It's about flowers, right? And we'll talk about that. I used to work at Microsoft, so we have some Microsoft data. Okay, and we'll talk about how to archive stuff, right? And sometimes, they say, Christian's on another planet, so we're going to talk about NASA. And we're going to look at all stock data, which is a CSV, and this is huge, versus Parquet. There's a temp directory. Oh, so we got a temp directory, which is a unmanaged table. We'll talk about that. And then we have USGS, which is the earthquakes, okay? So I think I've kind of showed you how to start a Spark cluster up. And let's talk about what a Spark cluster is, okay? So what is a Spark cluster? Unlike Databricks, and Databricks is moving away from this. I don't know if you noticed this, Christian, but Databricks used to be, hey, you had to pick the driver size. You had to pick the executor size. The newer versions of Databricks, when you spin it up with Unity Catalog, now you just pick and shoebox size. Like, hey, I want a cluster, and it automatically scales for you. Okay. But in the past, the art of Spark was tuning. Okay, and the idea of tuning is this: each one of these nodes is basically a virtual machine. So when you spun it up and it wasn't owned by Databricks, it wasn't serverless, it was serverful, I want to call it. It spun up virtual machines in your environment. And in your environment, you would have a task, okay? And a task or a slot, okay, is basically a place where you can run some code, and it's a single CPU. So it's single threaded, right? So basically, you got these Java virtual machines running multi-threaded. And basically, the trick was to figure out how to partition it. So if I had a big file, but if I partition it by 8, then I could run through one stage they call it, and I'd be done. It would be perfect, right? If I had 10, and this was my cluster, how many stages would it take? It would take 2, because the first one would be 8. And say that took 10 minutes to do. And the second stage, we'd have to wait for another 2, which would be now 20 minutes total, okay? So that was basically the art of Spark, and it's kind of going away now with this ML and stuff going on. Okay, let's talk about what we're doing and what's the difference between a lakehouse and a warehouse. Well, regardless of both, you're basically doing a data hub, right? So we have some sources here. A lot of clients I have, like ERP systems like SAP, Great Plains, whatever. Maybe you got some Salesforce. Maybe you got ServiceNow. Those are your spokes, and those are producers. They go into the hub. So your hub would be your lake, or back in my day, we would have, on-premise operational data source, they call them ODS, right? This could also be a warehouse. And then last but not least, the other spokes might be your consumers, like Power BI. Maybe you're using Tableau, okay? The idea is if you keep this data really clean, it could be a single source of truth for your company, because maybe you can't write a report that takes ERP data and sales data, but if it's in a lake, you sure can. Okay, so let's talk about the medallion architecture, and this is the picture that Microsoft came up with, okay? So we have files on premise, we have databases, so we're going to talk about this tonight. We could have other things like IoT coming into Event Hub, or business apps, which we're not going to show, but we talked about them, like Microsoft Dynamics. And I think, if I remember right, Christian's working on Microsoft Dynamics right now. Is that correct, Christian? You got a client on Dynamics?
No.
No, I thought you would.
That's
Oh,
fine.
it's healthcare. It was healthcare.
Healthcare, yes.
Okay. So basically, how do you get data in? It all depends, right? Right now, for the lake house, there's a couple of ways, right? You can use a data pipeline, which is ADF, or you can use a shortcut, right? And the shortcut is just basically a hot link to somewhere else, right? And I like to think of it as loose data meshing, right? So what is a shortcut? Basically, we point to AWS, Google, or Azure. We give it some credentials. When we create the table the first time, it goes out, make sure the credentials work. You can either, build from the source data, or if it's ready in a Delta format, it shows up as a table. If it's not a Delta, it shows up as a file, and we can process it. That can stay in memory with a cache if you enable caching. There's some rules on caching. Look at books online for details. And then basically, we want to, for each layer, as we go through this medallion architecture, want to improve the data. So this is bronze is normally called raw. So we just threw the raw address information in. And again, this is just an example. So now we have the address information, and guess what? Maybe I put street, but I live on Alberta Drive, so it's wrong. So maybe I write a program in Spark to call to Google Maps and say, hey, this is the address for John. Is it right? And it comes back and says, no, it's really Drive. It's not straight. So we update it in gold, silver, right? Now, that's great, an address table by itself, but probably has no intrinsic business value. And what's better is maybe all the people in their locations that we sold products to, right? Grouped by state or something like that. That would be our gold. So that means that we're taking silver and making some type of star schema, which Power BI loves star schemas, and put it there. The interesting thing is that everything that you do, the read and writing of files in the data lake, is done by notebooks or Spark jobs. You can also do data flows, but most people use a data flow or a data pipeline to just get into Bronze, and then they use Spark to do the rest, okay? The interesting thing too also is that this endpoint right here is only read only, okay? So it's very important. You can't write to the endpoint. Okay. So again, back to weak versus strong. Weak, CSV, easily broken. Someone takes a file letter. I've been called in the middle of the night. Put an extra comma, and guess what? Suddenly breaks. Might not have partitioning. It definitely, if you didn't put the header in, I'd have to guess at, hey, is the first column a name? Is it an address? I don't know. Maybe it's Alberta. Well, that could be a guy's name. I don't know. And so that's the reason why you want to stay away from these weak file formats, because if you're doing inference, okay, means you have to infer the columns and data types. You have to go through the whole file doing it. Now, there's a way around that. You can still go ahead and give it a schema when reading. That'll make it definitely not infer stuff, but you still have to go ahead and process the whole file. And especially JSON files, they're huge, a lot of bloat. CSV, not as much bloat, but there could be some bloat there. You're not going to get any really internal compression because it's not like a column store. So again, stay away from weak file formats unless you're stuck on it. Like if you have an API call, it comes back as JSON, sure, store the JSON on your raw, but guess what? Convert it to a Delta file on your Bronze. Strong type files. There's a bunch of them. Apache came out, a bunch of them, Orc, Avro. The most popular is Parquet because that's what Delta's built on. It's middle of the road when it comes to size and speed, but it's awesome because it's binary. You don't have to guess at columns. You don't have to guess at types. Like I know it's an so Social Security number, right? SSN. But that Social Security number could be an integer, could be an alphanumeric. I don't know until I scan the whole thing. Also, it allows two forms of compression. You have table compression and you have a compression of the file itself. So definitely go with strong file types if you can. Okay, so we're going to talk about our first example, zipping files for transport. So what is the OneLake? We talked about it, and I'll go back one right here, OneLake. This is where everything happens. Your data warehouse is here. You might hear the word KQL database. That's your real-time stuff. You might hear Lakehouse. That's all on OneLake, okay? But what is OneLake really built upon, right? It's built upon Azure Data Lake Storage Gen 2. It's not anything new, right? It's been around for 5+ years. So how can we get it to the cloud? One way is we can use a no-code solution, right? So we go ahead and manually zip it and upload it. That works. Data pipelines can use binary copy to move data into the cloud too, okay? If you have a zip file. So let's go back. If you're really curious, this is kind of how, oops, hit the wrong button. This is how a zip file looks. There's a header. In the header, it's a centralized directory. Has a bunch of listing of where the files are. And then it uses some type of encoding. Like back in my day, the big thing was run length encoding, right? But it uses a lot more advanced stuff than that. You got a header saying this is the start of it, and then you have the compressed data, another header, and so on. Okay. So let's do the example on zip files. Okay, so we cleaned up everything. Okay. Interesting thing. If we go to monitor, hey, look at that. Even though I got out of this, I can close the file, and I can close this one. it's saying, oh, do you want to stop and close it? Yes, I do, because if I don't, then it's not going to free up this resource. Okay, see this, it says in progress. And hopefully in a minute it'll say succeeded. So now it's done. Okay, awesome. So again, workspaces, when this came out, and again, it's been only like a year and a half, 18 months, if that. You couldn't make subdirectories, but now you can, which is cool. And there's a right click and you can move stuff too. So we're going to talk about zip files. Okay. So we know, and again, to run this, we have to go in here. And the very first thing is we want to start our cluster, because we don't have it to cluster, we can't do anything. So if we look at this goes files, stocks, all data.csv, and Parquet. So we're going to go to stocks. Right, we have these two. Okay, we're going to get rid of them. That's basically it. Now, this is good programming practice. Whenever you program, you try something, and if it fails, you say, oh, error out, maybe stop the whole thing. And this one, I don't care if they're not there, and it'll cause an error. I don't want to worry about it. Just keep on going. Now, one of the things you will notice in Spark, or at least Fabric, is this is all web services. So even though this might be done, over here, this might not show up right away. So we might have to hit refresh. And guess what? Now we just have the archive file. So how do we unzip it? Well, that's really easy. There's a file library called unzip, zip file, right? And so we say, here's the root path. Okay, so it's /wakehouse, the default, and then underneath it, files. And there's many different ways to set up paths depending on whether or not you're using, Spark or using other utilities. So there's a whole article I did on that. But for this one, we're going to say, okay, here's my file, zip file 3, and then extract them all. Okay, so we're going to run this. Okay, hopefully this doesn't take too long. I know this is interesting thing is I don't see any sizes. Can I go properties on this? Nope, there's no properties. Okay, so this is where it's going to take some time, because we can see, I'm going to go on to the next slide, we'll come back to this. This is doing a big extraction, right? Extract it, now 1.9, oh, they finished, so good. It wasn't going to go quick tonight, I was going to, so unzip these two, right? And now if we run this, we can see that the actual CSV file is 3.5 gigabytes, okay? And a 9.96 gigabyte Parquet file. Okay, so same data, two different formats. We can see that this is almost a quarter of the original file. Again, I'm just rounding up or down. So remember I said there's a lot of things and different ways to call stuff? There's mounts there. So if we click mounts, there's some default mounts. We already used one called Lakehouse Default. There's also /Lakehouse. But it really is Data Lake Storage, right? So it's ABFS. This big GUID at onelake.dfs. So, what do they call this? File system, but I forget what the D is for. And then we also have underneath here where it's associated with. And this one is associated with this Lakehouse, right? So we got the workspace and the Lakehouse in here, okay? Next thing we can do is we can define a function to find matching files, right? So I want to say get a file list. Well, we're going to use fnmatch. We're going to first get a file list, and I had this in Databricks. So I converted from dbutils to MS Spark utils. And then I say in the list, append anything that's matched, then filter it and return it. So basically, I'm going to run this, okay? And then I'm going to look at files in MSFT. So if I had more stuff other than this, which I do, 2 zip files, I said just return my CSV files, okay? And it's smart enough to say, hey, yeah, 1, 2, 3, 4, 5. I got 5 years of Microsoft data. Okay, cool. Problem is, zipping is a lot harder than unzipping, okay? And the reason why is that this is remote storage, and it's not remote like, hey, I mounted it and it's there. It's a service, okay? So we have to do some I/O. We have to do things in memory. So let's take a look at this function. We're going to zip up files. We need a folder, a pattern, and the final archive file. And what we're going to do is set some variables. Files folder, Lakehouse default folder, and we're going to do this pattern, okay? Get the file list. Okay, we're going to create a memory buffer. And in that memory buffer for zip file, we're going to append to it, okay? And then for each of the files, we're going to open up the file, okay, as read binary. We're going to read it, then we're going to convert it to IO bytes, getting the value as a string. Then we're going to write the string to the zip file. So we're still in memory. This is all memory. Then the very last thing, okay, is we're going to write it out using Python. Now, why did we have to do this? Typically, if we ran this on premise, this would work fine because we can write in a for loop over and over again to the storage because it's tangible. This is a service though, so we can only write to it once. So this is why we have to do it in memory, okay? So this one is basically defining the function. And then basically it's saying archive2. So I don't know why I didn't get rid of this, but I am going to get rid of archive2. Okay, so this is going to zip it up as archive2. And if we run back, that was pretty quick. Again, I always forget how long these things, and guess what? Now we have archive2. Does that really work? Well, guess what? How much time I have? I got a little time? Yeah, let's do it. So one of the things you're going to learn is that you're going to have to use Microsoft Storage Explorer. And I hope I have the mount, because if I don't have the mount, we're just going to pass on it because I don't have enough time to figure it out again. But attach containers, use the storage counts, blob storage, fabric files. Is this it? No data available. How about this guy? Oh, look at this. Presented multi-factor authentication has expired. So this is E. So did that correspond to E, or is it this guy? That's E2. So let me see. Refresh. Not let me. Okay, so the bad thing about this is because this multi-factor authentication, we'd have to go ahead and do a new mount, and I don't have enough time to do that. So I'll show you. Definitely have done it before. You can also look through online. I just want to make sure we get through this. If not, we'll come back to it. Okay, so delimited files. Basically, carriage return line feed if you're in Windows. If you're in Unix, right, you might have just the carriage return. So, or line feed, I think it is, /r/n. In Unix, it's just /n. Header is optional. So if you don't get one, use a custom schema so it doesn't have to figure it out. In the custom schema, you'll be telling the data type so it doesn't scan all the way. Okay, shortcut notation can be used when writing Spark SQL. If using read method, many options can be defined, such as quoting, choice of delimiter, and optional header. Please note, only managed tables, this is very important, can be used in the SQL analytic endpoint in the semantic model, okay? So let's do the next one, which is the text file. Okay, so this is here. I don't know if it killed it, but we're going to close out of here, so we'll close out of this one. We'll just double check it. We can go in there, and guess what? It closed automatically, okay? So now we'll go back to our example workloads. Oops, wrong one, my workspace. And we want to explore CSV files. You got to be kidding me. Let's try this again. Kristen, you see anything wrong? Anyone see anything wrong? I was wondering why.
Looking for what, John?
I was wondering why it closed out. Guess what? I have a Logic app that turns it off
Yes,
at 7.
yes.
That is not so good if I'm teaching at night.
No.
We'll fix that. Sorry about that. Okay, now we got our compute back. I right away I caught that one. I was like, what the heck's going on here? Why did everything stop? So we're going to explore CSV files next. And this might take a little while because, like I said, we had no capacity. There we go. Cool. Getting a lake house. Okay, so these shortcuts, okay? You can use shorthand notation to say, hey, under files, under stocks, okay? This is the one that we had this huge file. Show me the CSV, limit 5. So I'm going to run this. Okay, whoops, it automatically had to create it. So it's creating a default standard one. And guess what? It's thinking. It's running a job. And there you go. So we got the header. Oops, that's not good. We got, it has C0, C1, so it didn't know it's a header because I can't specify that. And we have the header as data, then we have the data. It's all strength, right? Because we can see A, B, C. That's not what we want, right? So we can run this. I'm going to skip over it. Oh, I can run it again. What the heck? It's not going to take that long. Maybe it will. And then this is going to say, hey, the schema is all string. That's not something we want. But we can work with it. If you know what the data types are, we can say where C1 is not equal to date, we can get rid of it. And then we can take each one of these and cast it to a data type, okay, and rename them. So I did that appropriately here. So a little more work, but you can still do it this way if you want. And again, it's going to take a little more processing because not only do I have to read in, but I have to cast it as a second step before presenting it. And what we're doing is we're creating a managed table. Create table if not exist. And thank God this is SQL because it's tabbed over. If it was Spark, it would have belched and said, hey, you messed that up. Because Python likes to have everything tabbed over exactly, okay? So 1 minute, 42 seconds. Okay, while that's running, we'll go to text files, go back and forth. So what's text files? This is the last thing you can do, okay? And it's like if it doesn't JSON, it's not a CSV or delimited, well, we can always do it with text files. The only problem with text files is it could be ragged right, ragged left, whatever. The problem is we have to extract it. So hopefully it's a delimited. This one, if we look at, it's pipe delimited. So we can do a split string on the pipe. But then we maybe look for a particular row, and if we see some data we like, whoops, sorry about that, see some data we like error status being a certain value, not like 200, which is good, then we want to keep it. Everything else, maybe we drop it, okay? So text file is the last resort, okay, if we can't process it using some type of schema in a format, okay? So this is almost done. And again, this is taking long, even with 16 cores, it's taking almost 2 minutes, maybe more than 2 minutes. And if you're curious, you can always go into here and find all the details about what it's doing. You know, the SQL interpreter, and look, it's running 0 of 28 for this long, and still running. So while that's running, it'll eventually show up. We could do describe, and I think it just did, right? So it ran longer than last time, even though probably last time I had less computing power. It all depends what's going on with, you know, Fabric. If we do describe extended and not do it, we can see now the data types are the data types we want. We can also see it says it's managed. So it's actually showing up under the workspace, Lakehouse, right? And then under tables and CSV stock 1. So if we hit refresh, we have it right here. And just like before, we can hit show last top 5. And this should be pretty performant because it's, well, you never know. Should be. And we can see our data types. Date's a date, years string, month a string. Oh, actually, it's a number, sorry. Ticket's a number. We can see these are whole numbers versus floats all the way down, okay? Let's do it a different way. We can drop the table, and we can say if a table doesn't exist, then we can recreate it given a path, tell the header is true, and guess what? I'm going to say you figure it out, right? Infer the schema. And this one takes a lot less. See, 39 seconds before the other one because we gave it, tell them to infer it, and we don't have to read it twice. The one when we put it into memory, that's the first time read. Then when we went to process it, right, and cast it, it did it again. So it has a lot more job steps there, right? This one has 2. The other one had 3, okay? And we can see all the rows. Look at this. It's 31 million rows. That's a lot of stock data, right? 34 million. And it tells how many gigabytes, 3.27, okay? So now we do the top 5. And guess what? We have the similar option. Ooh, stock splits. I didn't see stock. Maybe there was stock splits before. I don't remember seeing that. But did I get the same thing? Yeah, I go 1 there. This came in as ABC, which is interesting. So it's totally different there. If we describe extended on it, we can see now this is external. It actually created it. Okay. But we put it as a file path. So if we look at file star CSV, not exist. Why am I doing it? Hang on. Why does it say external? Oh, because when we did this, we said using CSV. We didn't say create star. We're actually posting this as an external table given this. So you can see now if we hit refresh, we'll have 2 of them. Okay, so that's the difference between managed and unmanaged. Internal versus external tables, they're the same difference depending. Let's do it yet another different way, okay? So we're going to create a custom schema instead of infer it. We're going to read it up this time, CSV, header, infer the schema, custom schema, the path, right? And then we're going to save it, okay? We'll save as table is going to create a managed table. And again, the problem with this one is if we did publish this, because it's external, it doesn't show up in the endpoint, which is a problem. And again, let's see how many stages this does. So that's first stage. Okay, I'm going to multitask because it's going to take a little while. So let's talk about JSON files and yet another text file. JSON files became really popular, okay, with REST API endpoints, okay? So JSON stands for JavaScript Object Notations, an open standard. So basically you're making stuff readable, right? To store and transmit data objects, okay? There's actually something called, if I remember right, CData for binary. You can do, what do you call it, 64-bit strings, okay? So you can even send binary as text, okay? You'll see this if you use REST endpoints. I do a lot of REST endpoints. Problem with it is bloat again. Remember, you have to put key value pairs. So John, first name, John. Last name, Minor. First name, Christian. Last name, Cote. So on. Michelle, first name. Goats, last name. So with all that, you get redundant of the tags, right? And that could be a lot of redundancy if you have a lot of rows, okay? So this one's done. Let's take a look at it. So we're going to describe it again, and we can see now it's a managed table. Awesome. And then we should, if we ran it, we should get the same row count. So we get the same row count. Awesome. And if we hit refresh here, we should have a third table. Okay. So we're going to stop this cluster. Going to close this guy. Going to go back to the next one. So demo. Going to talk about text files and then JSON. So drop table if NASA exists, and then create table from NASA. Okay, great. So I'm going to connect to a new standard cluster, click that lakehouse. Again, NASA's here, so we got a HTTP logs from like 1995, old stuff. Thinking about starting it, so it says it started, which is awesome. So now I'm going to run this, drop the table, and if not, I'm going to run it. And if we look, 2 jobs, 3 jobs, pretty much it's finished, okay? Next thing, we can describe it, and we get a managed table. Awesome. I'm going to skip over some of these things. So now we can drop the second one, and this time, the first one we did create table, and we did select from text, okay? Second one, we're going to do create table using text and location. So this is a what? A unmanaged table. And we can see right here that that external is unmanaged. And if we look at the location, it's not under /tables, which is over here. It's under /files, okay? So if we go back to tables, hit refresh. Is this still running? We got the 2. So we got 2 text files. So we did that one, did that one. Okay. So did we do a text 3? So I'm sorry about that. I'm getting a little lost. So we can show some sample records. And again, should have got a cup of coffee before I started this. Or a beer. Then I'd go to sleep. And we can see this is requesting host, date, time, request, status. So we want to look for statuses that C304. That's a bad status. So we want to look for the one. So we can do with CTE, look at text 1. We can give it a row number. Okay. And then we can replace, we can split and pick the third one as the method. So it's going to be either get or post or whatever. It's getting an image right here of the countdown, right? And we can get URL. So this is our URL status code. And the response, I think these are a little off. I don't know why. Okay, the response is in milliseconds, okay? And the URL is the status code, okay? So we got our data there. So basically, you know, text is the Swiss Army. If you can't get to the data any which way other, use the text. You definitely can parse it. Let's talk about some JSON files. So again, JSON files are very common. So we're going to use the earthquake. So we're going to create from JSON. So this is the shortcut again. Then do the backtick and the path. It's going to create it. So lakehouse, going to connect to new session. It should start up right away, like 4 seconds, because I got the compute going already. Maybe not. Maybe it doesn't like me. There we go. Took 6 seconds. Okay. So this one's going to be managed again because we're saying create tables, select from something. So create tables and select from, or CTAS as, is always a managed table. After that, we're going to look at, hey, we can pick some fields like coordinates and so on. Now the problem is with this, if we didn't, we have some that are nested, like for instance, properties.time, properties.type, mag. So we can do each of those. Even though it's nested, it's going to pull it out. Unix timestamps, we have to handle them. Divide by 1,000, convert to Unix. Time zone, we can divide by 60, so we can tell how much, which one. It's -8 back or whatever. So GMT -8. Okay. If out of this lesson you don't learn anything, this is probably the most important thing. If you ever do data frames all the time, which I do, this is an awesome thing. There's something called schema.json. And basically, you know what this does? It takes this huge thing that I showed you right here, which is I just basically copied sample row in. And what it's going to do is it's going to give you the structure for it. A lot of times when building structures, I get lost. Okay, so we can do that, and it'll come back with the same one. Now, say we want to use that structure to parse it instead of just like saying, "Hey, you figure it out." Well, we take that code we get here, just paste it in, and there's PySpark.SQL.types. And in there's something called parse data type to a string, and basically it's going to bring back a struct type. And if you've done a lot of Spark, you know on a very complex struct type for JSON, it could take a long time to figure it out. This just automatically does it for you, which is awesome. And then the result was custom schema, right? So I'm going to use that custom schema here. Big thing is multi-line to make sure that's true. And guess what? Now I'm going to suddenly create a view on that data frame. And if we take a look at the view, okay, it's going to give us the features, but they're going to be nested. So what we're going to have to do is we're going to have to explode it, okay? And there's interesting things like implode and explode for commands for JSON. And basically explode means take it and bring everything that is underneath, make it a first class citizen, like name and ID and so on. So we can see the schemas there. So we're going to explode it from that view, and then we're going to select certain things, right? And guess what? We're going to get the same data we had before. Okay. And is there anything else to talk about? Oh, yes. So if you were doing this in code, after testing it, you would put it in as a statement and say, run the statement against a temporary view, and then save it as a table. So this is going to give us our third type, okay? So every time I've been showing you different ways to process the same data, using external versus internal. Again, Fabric likes managed tables, which is internal. So now we can see, whoops, did I skip over two? Let me look. Maybe I did. That's one. I think I might have did them out of order for this one for some reason. Okay, right here. This last one is creating an external one. So we're going to drop the table. If not exist, using JSON, just do it. And that's going to infer, right? Okay. And now we can describe it, and that is going to be external. We hit here. We should be spot on our JSON. Awesome. And then if we run it, we'll get the same record counts, okay? So anytime, if anyone has any questions, please just speak up. If not, we're going to start going into our strong data types, okay? There's several of them. I think I'm just going to focus on the Apache one, and then we'll go maybe see if we can get that blurring working. So what is Apache Parquet format? This is it. It's kind of complex, right? So it's a binary format. Metadata is separated from data. Instead of being row-based, like a CSV, it's column-based. So we can see that we have basically column B, and then we get some metadata, and then we have all these row groups, but that's your file, that's your footer. And so it lends itself really to partitioning well, okay? And a lot of times for compression, you already got column compression, but then you can compress it on top of that, okay? Apache Avro. So Apache Avro is one of three formats, right? It was made for remote procedure calls, okay? Interesting thing is that the metadata in the file is stored as a JSON format, okay? So you can see that the header has this metadata, which is some type of JSON. But then we have the count of bytes and blocks 1 serialized and the 16 mark. So we have repeating rows that are serializable, okay? Awk. Well, awk, okay, was based on Hadoop's. They tried to fix it. Problem, RC file format. Variety of compression techniques on top of the column store format. Cool thing about awk is that it allows for predicate pushdowns. So you can say, hey, I want only column 1 for a certain size, And once you get into the petition, it knows, hey, just skip this whole petition because something doesn't match, okay? And so also it kind of reminds me of Snowflake. It has min-max of, the indexes, so you can find things really quickly. If it's not between 1 and 10, skip to the next one, okay? And Delta. Delta is the next format that's really important too. So we're going to go skip the other two. There is code out there for it. I'm just not going to have enough time. Well, maybe we can try it. We'll see. If you don't mind going to 8 o'clock, Christian.
Oh, good,
Jason?
John.
No,
Okay, cool.
no, we go with it. 7:55 might be perfect.
Okay, perfect. I will try to get everything wrapped up by then.
Perfect. Thank you.
You're welcome. So this one, we're going to go back again. We're going to connect to the new standard cluster, and that once that starts, we can kick it off. So we're going to look at create table if not exist, and we're just going to read from a Parquet file. We're going to do some interesting things. We're going to have date as a date, but then also we're going to get the year and month of it, and this is just stock data and stock splits, okay? So we'll run this. And again, it's going off the stocks, and there's a Parquet file here, okay? And this will publish it as a table. Now, if you remember last time we ran this took like a minute or so, right? While that's going, let's take a look at Storage Explorer. Whoops, wrong one. I wanted Storage Explorer, and I brought up Star. There we go. Okay. So the interesting thing is that when you sign in, you get all your Azure stuff, but you still can use Storage Explorer with Fabric, okay? A little trick is you need to go, where is it? Not this guy. Again, I'm remembering this off the top of my head. We need to go to storage account of service, right? And we're back. Let's make sure. Nope, it's this guy. Using OAuth. There you go. And then what we'll do is we'll do crafty DBA, hit next. Okay, so we need, let's call, okay, and then I need the place of where the storage is, okay? So we can get that by going back to Fabric, and did this finish? Oh, finished, cool. Take a quick look at it and we'll see if we can get it. Okay, so we have it there, and what we can do is now, if I remember right, and again, it's top from memory, we want to just basically copy the ABFS path. And yeah, I forgot. Let me take a quick thing at my notes. And we'll go right back to this. There we go. And again, I don't do this all the time. It's just like one of those things that you do once in a while. So I think it's this one right here. It's the hardest part is remembering the format, which is not the typical format that you usually use. And hopefully I don't go take too much time. So let's say, nope, it's not here. Format, so Fabric, OneLake, format for for Storage Explorer. There we go. It's not that. It's not that. Okay, it's here. That's not it. Of course, it's probably not going to tell me what I want. This is the One Lake storage. I want Azure Storage Explorer. There we go. Perfect. This is it. Right there. So One Lake, display One Lake. I need One Lake DFS and then the lake house, I guess. Try that again. So we go back here, and what's interesting, I had this set up, but it decided that the security expired, the multi-factor, and then it just didn't work anymore. So this is the One Lake. That's my workspace. Okay, let's see. See that other one, so we'll see. Try this. HTTPS. Does that like me? See? Yeah, it doesn't like me. And I wish, the thing is that Open Explorer, that these older ones that I did here, let's delete, detach, yes, that were working. I wish they had like a way to refresh it, see? And there's no way to look at the properties. Very frustrating. Anyways, we'll try it one more time. Just wondered, this OAuth of this, right? So there's this guy, right? This guy. That's fine. That's fine. Best. Okay. Let's go back to the article. If not, we'll move on. One Lake. So basically, what we're doing is trying to attach to the One Lake. So this says One Lake Workspace / Lake House, okay? So let's try doing this with this. Control C. And go back one, do a / here. Okay, let's try that. And this example says, oh, interesting thing is, guess what? The slashes are going the other way. Let's do that. I don't know why the slashes would be going the other way, but whatever. Maybe because it's on Unix. Okay, where was I? Storage Explorer, paste this in. Endpoint is not known blobs. If I go back here, yeah, Z. Next. Yeah, that's not making me happy. I wish I knew what it was. I've had it before. So let's just close out of this. I was just going to show you that once it's zipped, you can download it. There's many tools here. The Storage Explorer, PowerShell works really well. I just don't have the URL in my brain right this time. So we were talking about Parquet. So we hit refresh here. And we did the JSON, right? This is thinking now, so it's running through. So Parquet is one of the favorite formats. I'm going to skip over Awk and Avro. Avro is really good for reading. Awk is the most tightest format that's out there if you look at size. I have a whole thing on MS SQL tips. So another way to create is just create table using in the path, right? So we can see this is create table using. So that's going to give me a unmanaged table, right? Because if we look, then we go here, it's external, right? Perfect. Let that run. And what I'm going to do now is, if we hit refresh, we get a second one. And basically, I didn't do any other ones. So we're going to basically get counts, right? Take a look at both of them. And basically, it's a date, ticker, open, high, low, close, volume, dividends, and stock splits. And we get the same number of rows. If we look at it, it's 34 million. Okay, cool. So let's close out of this example. I talked about Parquet, stop and close. I'm going to, why does this say make patchy? I'm just curious what this is. Okay, so this one shows you that if you create certain, oh, this makes the Avro and the awk files because I didn't have an example. So if you're curious, run that, you'll get it, and then you can play with Avro files and awk. We're going to go right to Delta because Delta is the format that everyone's using, okay? So we're going to import pandas and we'll show you, hey, the iris, right? We can use pandas, why not, right? And pandas is available now on Spark 2, right? It's a new standard session. You can also run pandas. We talked about that on a Python-only notebook. If we do the top 10, it gives us a header row like that. We can see that there's an ID, and we get the column lengths, both width and petal lengths, and the species. Okay, and then basically the clustering algorithm, right? So we can drop the table, create table if not exist, and then we can select from it. Okay, so if we run this, okay, and now we hit refresh. Okay, you might say, "Hey, John, where's the data?" Right? And the answer is, I don't know. We dropped it and created it, but we didn't put anything in it, right? So it's an empty. It's taking a long time to create an empty file, but it's there. Okay, so now if we hit refresh, we can see there's an empty Delta file. We can go ahead and do the history of it. History is basically time travel. Because there's Parquet files in Delta, you can say, hey, the first one is create table. I didn't do anything with, right? Now, what we can do is we can say define process row. We're going to do an insert statement, okay? We can do a bug. And then what we're going to do is we're going to define this process row, and we're going to apply it against it. Now, this is something that you should not do with Delta because know why? It's going to create 150 files. Is it quick? No, it isn't. In fact, I just recently wrote an article. Whoops, why did that not work? PDF not found. Did I miss something? I probably PD pandas. I did write this, right? Maybe I didn't run this. There we go. I created that. That's definitely did history. Let's try this again. So remember, every time you run something like this, okay, it's going to look at this. It's going nuts because it's running an insert for each of the 150. Okay, it has to create both a Parquet and a JSON file, which is basically your log. Okay, there might even be a checkpoint file for have something going on. And so it's just spinning up jobs. Like, look at all these jobs. It takes a long time. Now, this is for 150 rows. It's going to take a long time. Imagine if I tried to do 10,000, which was a date table in the warehouse that my article is coming out. That took like 20 minutes. That's crazy just to insert 3,000 rows. Now, the better way to do it would be to come up with one SQL statement that has multiple rows to insert, or better yet, just do an update, okay, from a data frame using the merge method, okay? I don't have time to teach that, but that's something you can do as research. So this is still going, and what's going to happen is at the very end, we're going to see that it's 150 different versions, okay? And if we look at the versions, we can see it's how many files? One file. And how many rows? One row. So that's a long way to do it, right? Now, this one is using the merge. So stand me corrected. I did write this program. always forget what I do sometimes. I do too much. And then I will wrap up. I'm running out of time. I will wrap up the slides and we'll call it a night. The main thing is this will create 150 files. Let's look at the way to do it the fast way. The fast way is to create a data frame from the pandas. Then we're going to basically rename it, okay, to something that I like. Then we're going to put a path to it. And then from that path, what we're going to do is we're going to say for path, Spark, right? We're going to create, and this loads up the file, right? And then what we're going to do is we're going to merge into it where target equals source. So basically match all, execute. And then if we look at the file rows, we can see the file rows. We can also do updates, deletes, inserts, just like this was basically a our DBMS instead of a file type format. So that's why everyone's using Delta, okay? Let me wrap it up. So again, why use Delta? You get those ACID properties. You get scheme enforcement, which you talked about time travel. There is some snapshot isolation, but you can get collisions. There's a whole article. Go read MS SQL Server Central. It talks about update collisions. It's an open source, and that's why Microsoft took the open source format and built everything on top of it, okay? And Databricks came out with it. Okay, relational databases. Just remember, place the secrets in a vault. Okay, you have to load the driver into the environment if it's SQL or if it's Postgres. Write functions of read table and return a data frame. Save the data frame to a new lakehouse table. Why I say table? Because unless you're doing, remember we said don't do small changes. We want to read everything to memory, which would be into a data frame, and then write the data frame back to the table. So just major block write to it. Okay. A way to do it is you can use metadata. Look at the example. It's a lot easier to do. Summary. Basically, what's different, right? Microsoft's the one-stop shop for your data and analytic needs. As a developer, you can pick the architecture you want to do. You can do a lakehouse. You can do a data warehouse. You can do machine learning, real-time Kusto database, okay? What I didn't show was Copilot. So to get Copilot, you have to go ahead and use the F64, which is around $4K a month. Very high entry point for small and medium customers. Go look at OpenAI. I've been doing a lot with OpenAI. If you know what you're doing, like, hey, SQL, and you can do a metadata-driven design, you can parse a lot of stuff into code right away and do that generative AI, generating code, so you have to do less, okay? Yes, there's several bugs, like I was telling Christian, that stupid bug for listing came up again. Basically, they're adding more sources to Lake as well as real-time. So basically, if you keep your skill sets of SQL, Python, and Spark up to date and learn about these new product offerings, basically the future is bright. You'll be totally employed, okay? Bunch of links. Lakehouse, notebooks, text format, CSV, JSON we talked about. Avro and Orc we didn't get into, but those Avro is again for I remember off the top of my head is, I'm not going to go there. I think it's something to do with REST API calls or streaming or serialization. Orc is it's serialization. Orc's the replacement for RC. We talked about Parquet. Delta's built on Parquet and basically just the JSON connector. And that's it. Stock data, NASA, where you can get the data, Pubs database. Any questions?
I think, George, one question we have is some people want to get the slide deck, right? So
Yep.
I think you published before your GitHub link.
Yep, I will
this
show you
meeting,
that.
right? Yeah.
Yep. So unfortunately, it just randomly picked something. So I'm going to do GitHub and then John -3. And here's all the presentations. I've been doing this for a long time, like Christian,
Perfect.
like 15 years. But if you go all the way down to understanding lakehouse formats, that's the PPX.
Perfect.
I actually put the Postgres driver in. You can easily get the SQL drive. It's not that hard to find. Here's some of the files that we talked about. There's actually even 2 records, which I didn't get a chance to place around. And here's all the actual notebooks. So if you're curious, like when you download a notebook, I'll show you in, VS Code. If you have a notebook for anything, you just type code, right? Install code. And then you could do it offline too, right? So this is a client, like I told you, I was working on it, and I'm doing some T-SQL. And this is basically right there. That's Markdown, and that's some T-SQL there.
All right, thank you.
You're welcome. Any
Any
other
other
questions?
question, guys? Yeah. The chat. I guess you were clear, John.
I don't know about that. I think the biggest thing is we need to tell Microsoft start reintroducing the same bugs over and over again.
Yeah. Someone is
I'll paste
asking
it
for the
in.
link
Yeah,
to
I got it.
GitHub.
Yep, I will paste it then.
Yeah.
So again, main links is there's 3 things you want to learn about me or learn from me more. I'll put them in again. This is my GitHub. Yep. Second thing is if you're curious, all the things I teach about, I usually reinforce with a article, right? So if you give me a minute, I'll paste the articles in. So MS SQL tips.
Yep.
John Miner, I have almost 125 articles here. A lot of them do with Azure, a lot of do with PowerShell, which we do a lot of, Databricks, Spark, right, SQL. So that's it. And then the last thing I'll publish is all the new content I told Steve Jones I would do. So if you want anything on Fabric, this is definitely the place to go to. I want to thank you again, Christian, for having me, and I look forward
Thank you,
to seeing
John.
you soon.
Yes.
No, you're not going to. Are you going to MVP?
No, but are you going to
yeah, that's what I
Houston?
said. Yeah, you told me you're going to
Are
China.
you going to Houston?
No, I'm not going to Houston. I'm
Yeah, I
going to
see. No,
MVP, and
okay.
I'm going to Las Vegas.
We might see you because something that I am waiting for a date from Microsoft here, but between May 17 or June 14, we'll have a SQL Saturday here in Montreal. So you'll be welcome.
I
will have the date
attend.
confirmed
It's been
next
such a long
week. So
time.
yeah, the call for SQL. My God, the call for speakers will be out next week for sure. So yeah.
Yes. Thanks again for having me. I know it's
Thank
a
you, John.
lot in here. I wish I had
Michelle,
more
you
time
there?
to go over it. But
Yes,
I
I'm
appreciate
here.
it.
Yeah, good. All right. Thank you, guys.
And Michelle, keep on flipping around.
Thank you.
Backflips.
She will.
I also
right.
backflip on Fabric now.
I'll give you a quarter every time you do it.
All right, guys.
Thank you.
Thank you
Have a
very
nice
much.
night. Thank you, everyone.
Thank you.
Bye.
Bye-bye.
Bye.
Thank you.